go live. Oh, now I did. Hello, hello. As I warned you in the chat and in Code Forces, I'm not going to read YouTube chat today. As said in, for example, YouTube title, go to Twitch for chat. I will only see Twitch chat. Need to move this here, open Genie. In a moment I will show you my screen. What's going on here? I don't need you. No, okay, now I can show. I can show. Here we go. Remove everything here. I have my templates. I have my files. Default scoring. Easy win today, hopefully. So far, always I was 500 rating better than my opponent, and still I lost once. And today I'm facing somebody stronger than me. That's kind of bad. I need paper. I'm reading only Twitch chat today. So just disable this one. Okay, YouTube chat will exist, but I'm not reading YouTube. Sorry about that. I feel stressed a little bit because I will go out of the competition if I fail. Well, that's life. On Code Forces I pinged. Oh, no. So let's go. Round. Oh, not. Let's go. Do I know Merkurev? I met him in some programming camps. He was also in Code Chef Snackdown. I think he won there. Maybe as well in ICPC, but mainly it's Petrozavodsk, Moscow. Let's go. "45 minutes. It's now 6 minutes after start of the stream, so I need to remember that 51 minutes is when things end. Oh, and close the window. We're getting close to the end of this tournament. Okay. There is gap between those two and those two. So it's good to solve C, D. Good luck, have fun. No spoilers in... do I have... I need to quickly check if for unsolved problems I see tags. No, this... Okay, I don't. What a stupid problem. A very easy one. Wait. Oh, like that. Okay. How do I do it? It's crazy what is happening here. Okay, I'm doing something stupid. Instead of all those ifs, I will just create a grid. Of size D. By C, filled with dots. Horizontally. And call smaller than this. And is horizontal. Yeah, warnings, whatever. Shadow. Nothing solved. I need to chill. I stress too much. Okay, compilation successful. Horizontal. Row, column, D vertically. C horizontally. Row D minus 1, column A minus 1, E horizontally. B minus 1, column C minus 1, E vertically. This and some extra conditions. Is that enough? What did he solve? 300, that's fine. This is promising. First submit. But wrong answer on 5. Fuck. What else do I need? I guess I need to print something, don't I? Impossible, I don't print it. Not a screenshot, thank you. Okay. What else? How can there be no sample with answer impossible? Still same. Wrong answer doesn't cost, no. I didn't know about that. Lexicographic minimal. This is empty. Our grid smaller than us. Give me accepted. No. Just remember, no spoilers in the chat. I don't know if for such an old problem they still don't care about case. Accepted. Oh. Just don't touch those two. 400 or these two. I wonder what he's doing. Hard to say. And then I don't know which one was which. Can I solve this? I can challenge him on this. I will read. What? Is it from regionals? That shouldn't have standard difficulty. Create a tree or a forest with some particular sum of depths. That's easy. That's very easy. Am I looking correctly? Sum of nestings? Sum of nestings? Yes. Let's try. Maybe I'm fast enough. I don't know if that's enough. Wrong answer. What am I doing? 3 and 1. Did I win? Did I win? Oof. This problem D was so easy. This just says create any forest with n vertices and the sum of depths must be exactly k, and you can do it greedily. Just create one path, and whenever you are too deep and the next vertex would overflow k, retract, just cancel by 1. What is Lockout Championship? I still don't remember, don't have time to do it at the beginning. There is something said in the description, there are some links, you can read more about it. But it's a 1v1 tournament. I will show you the rules and brackets in a moment. And because we are at, what, 26 minutes of the stream, I guess I will move to some problem solving of Codeforces problems now. Geothermal. Done. For the first time during this tournament, I felt stressed. I felt that I will likely lose. If we are on Twitch, I think there are some links here. Yes, see brackets. The rules are described here, but also there are brackets. One loss is allowed. I lost against Is This FFT. I'm somewhere down now. Yeah, I now won against Merkurev and will face Game in the next round. Here we have Game. Also, related to this guy, let me advertise my new Discord server. Yesterday I had a stream where I talked with the audience and I finally decided to make one. Link is here. Link is here in the description. I will paste also in the chat if you want to use it. And Game is, I don't know if it's on purpose after all, but Game is admin of that Discord server. Who runs this tournament? Geothermal. Hats off to him. It's so amazing that he spent so much time on this. Oof. Cool. In a moment, as I said, I will move to problem solving of code forces. Maybe I will finish the last code forces round. Also, tomorrow there will be stream on same time. Ignore this schedule. I will correct this. Tomorrow also 5 p.m. Central European time, just like today, there will be a stream. I will do couch of problems. Adrenaline rush max. Yes, I felt the adrenaline. And that's very pleasant feeling. Reading chat for a moment. Short stream, yeah. What if the contestants already seen problems? The bot choosing problems makes sure that we didn't solve it. It's possible that we saw it, but you cannot avoid that. If I saw a problem I recognize, I would tell that. The satisfaction after winning is awesome. Yes, I have recently similar thought about video games, where if there is no checkpoint for a long time, or you have very hard battle, you died 20 times, that's the feeling of satisfaction where you eventually beat it. So similarly in contests, winning Division 2 isn't really pleasant compared to from time to time succeeding in something indeed difficult where you are an underdog. I'm not saying that here. Lockouts are quite random. Even against tourists, I would have more than 10% chances to win. I'm guessing. I didn't face him yet, but it's quite random what is your order of problems and whether you are lucky that problem you're trying is easy. And I was lucky with second last problem. And also with the last problem. I can read quite fast, so in first seconds I open multiple problems and I then decide which one to go with first. And I quickly realized that the first few problems looked ugly, long. I considered problem C first. It was something about GCD. I had enough time to read it. Where is it? Oh yeah, when I first opened this one, it looked like some kind of construction. We choose some number, we move GCD to the end, and I just guessed that it isn't a trivial problem, and the last one was a trivial problem you just need to implement. The issue with lockouts, the bad thing about lockouts is that you don't have time to read the statement. I only read the first paragraph, I read the here samples, looked at them, and that's it. I started implementing and got some wrong answers because, for example, I didn't see that we need to print impossible. I didn't see that we need to print lexicographically minimal solution. I need to finish reading the statement before implementing, unless it's a very easy problem. For questions like keyboard C FAQ. Exclamation mark FAQ. You can cheat, like if you are likely to lose, you say you have seen some problem and stop the match. There are easier ways here to cheat. I can just, if I didn't stream, I could look up the editorial of a problem. It's all about trusting each other. Will you come to Discord for a few minutes every day? For sure, in the coming days, I will spend at least 1 hour on Discord every day because I'm setting things up. Can I show you Discord, or is there a big chance that there will be a lot of ugly drawings when people realize that I'm showing this on the stream? I wonder. I cannot accept invite because I'm already there. Okay, this is what I can show you. What do we have now? Nothing interesting, really. Half of the server now is discussing what the server should be about. Yeah, I don't get the current internet and its memes. Anyway, let's maybe solve some code forces problems. I saw some cool things in bot. Wait a second. And if you have any suggestions better than Errichto server official, I didn't even choose that name, one of the admins did, then let me know. Bot usage. There is something like problem distribution. I need to find it. Plot solved. I think I need this. Oh yeah. This is distribution of difficulties of problems I solved in code forces. And most time I spent on code forces was when I was weaker than currently I am. So it's not that currently I usually solve problems around 1500 rating, but it would be nice to shift this a bit more to the right. So what about we try some 2800 problems? Just to make this graph look smoother. Thank you for congratulations. 2800 sounds good. It's lagging for me. I don't know. The stream seems fine for me. Any suggestions for a cool problem with difficulty around 2800? 2800 is a lot, isn't it? It's like division 1E. I'm looking for the problem set. Can I post a link to a problem? Yes. What does 2800 mean? In code forces there is some difficulty heuristic. 3000 means very difficult problem, 500 means trivial problem. Check this, please. I'm not doing CodeChef today. I'm doing code forces. Is the problem by game really cool? This one? I got those two suggestions. Let's do some centroid decomposition. I don't know. It's not that interesting. I want to show tags. I don't recommend you practicing this way. You shouldn't see tags in advance, but I'm going to see tags in order to, in particular, see the difficulty. And 3500 is too much. No, thank you. 2500 and geometry is fine, but maybe a bit too easy. Do we have something more difficult? How can I join Discord? Use the link from description. Try this. 2800, okay. I saw, I think, 3 and divide and conquer, but I'm not going to continue. Is it some recent thing? 657. Okay. Let's do this one. I will copy paste the link. YouTube asks who won. Again, today I'm focusing on Twitch chat. Sorry about that. So the only thing I'm looking at is this thing. And if you're watching on YouTube live and you want to chat with me, go to Twitch. This is an experiment. I'm seeing how it goes. I won. Regarding the question, who won? Okay, I'm closing this, and we're doing this problem. I copy-pasted in the chat already. Okay, skip this part, definitions. I mean, skip. I've read it, but it was a waste of time. Person I is imbalanced. Both parents specified. Or maybe I shouldn't skip it. Oh, each person has exactly one child, so the naming is reversed from the standard naming. Ancestor is something below. Ancestor is actually descendant. No. A is ancestor if A has a child, so something up. It's ancestor, okay. So ancestor means descendant. We say that person A is imbalanced if both parents specified and the total number of ancestors of one of the parents is at least double the other. Sure. Number of imbalanced people in the structure and got K people in total. So create something like imbalanced BST, not necessarily BST, but binary tree with some number of imbalances. Sounds fine. Do I think you can compete in Python? Yes. And this question was asked multiple times. Use Google. I'm getting a drawing tablet. There is an extension which shows only rating, not tags. I don't want a 10th extension. I have too many extensions already. Okay, in order to make drawings, I need to do something first. Because my drawing tablet doesn't like Linux, or the other way around. I need to follow this thing. So first, hold two buttons on a tablet, the leftmost and rightmost. This resets it. Then type this. Why can't I copy? Oof. My whole computer froze. Was everything okay with the stream? No. Can I... If I hold the two buttons again, will something bad happen? I think head 0. I would make a script for this, but the names are non-deterministic, the IDs are non-deterministic, so the script will be more complicated. But I will do it in a few days. Okay, I think it all should be head 1. And here we go, I can draw. Does anybody know how to make Sornal to have the same background by default every time? Okay, after 5 minutes of setting things up, we can solve the problem. The problem is we're given n and k. I need to construct such a binary tree that there are exactly k vertices of some particular property. Of property that the size of one subtree is twice bigger than size of the other subtree. Then vertex is imbalanced. Can I greedily do it from the bottom or from the top? What is the smallest tree for which I can get k equal to 1? For any k, I need to say yes or no. So what? The total number of ancestors of one of the parents is at least double the other. So this is the smallest example, where k equal to 1. What about k equal to 2? I can write a brute force iterating over all binary trees, and it will show me the best shape for every next k. I can do this. I can keep doing this. By adding two vertices, I will increase k by 1. And how efficient is it? I think that's very efficient. In a binary tree, if there are n vertices, around n over 2 of them are leaves. So the remaining n over 2 are non-leaves, and only those can be imbalanced. Then maybe this is the best I can do. I highly doubt it. That would be too easy. If n is bigger than what I would create here, because now for some k I want to minimize n. I want to create smallest possible tree with this number of imbalanced vertices. If I want bigger n, then I will just add more here. I will make this more balanced. I will put the things in this order. Does somebody know a problem? Can you tell me if this is wrong already? What happens if I implement this? Okay, I will implement this in around 5 to 10 minutes max. Then if I get wrong answer, it's either about some simple bug, format error, or it's the issue with my solution. And I'm guessing it's the issue with my solution, because then problem would be easier if what I said is correct. Then you can't make the tree that you just made for k equal to 3, right? You either have both parents or none? Oh. Indeed, either both parents specified or none. So this... It was not correct for me to say that this is the minimal tree. Okay. This is bad because there is a vertex, this guy, who doesn't have both children. This is bad, forbidden. Instead, I can do this and I can do that, but I'm guessing that we can achieve something better than this. Right now, those I'm marking are imbalanced. Okay, but still it's true that only one vertex is wasted, and there will be the deepest non-leaf. The deepest non-leaf must have exactly 2 leaves, and that's it, and then you cannot be imbalanced. I think that this is still optimal. Say k equal to 3 and n equal to 11. Oh, the question is now whether I can do something about it if n is bigger. Also, n is odd, isn't it? I think that we cannot do anything if n is even, because every tree will be created by having first the root, and then repeatedly choosing some vertex and saying you were a leaf, then now you have 2 more leaves. Or like we say, this vertex, no, 2 children. This vertex, 2 children. This vertex, 2 children. This way always n is odd. Okay, that's first thing. Second is, forget about that. Second is now, this way for particular k I minimize n. But what if I want bigger n? I cannot append here. I can maybe append here. I think there is no issue with that. So what about what if I need to do it multiple times? If just once, then do that. Otherwise, let's say I need 10 times to add something. Let's see what I will do. Those 2. Then can I just keep adding like that? What then? Is this problem just about figuring out some details like this? Still seems too easy. You can Google this problem if you want. It seems too easy. Or maybe the difficulty is broken because it's from Division 2 contest? I didn't want to see tags. What I can see, let's say for the sake of for understanding the difficulty, is standings. Not like that. Enter the contest, then inverse genealogy. Okay, people solved E after 1 hour. High red people. So I'm doing something wrong. Or just what I'm doing is very difficult to get correctly. Are you allowed to read Twitch chat during lockout? I'm not allowed to get any hints. And when from time to time I'm taking a look at the chat, for example, to see that something is wrong with the stream. But if then I see there's some hint, a big hint, big spoiler, that's forbidden, that's cheating of me. If that would really help me, and if I couldn't solve a problem and saw such a hint, I would need to switch to the other problem, I would say. Okay, I have this series of additions. Then I can add 4 more here, 4 more here, then 4, 4, 4, but I cannot break it. What about adding the biggest possible power of 2 here? Let's say that I add 16. No, that's not 16 because I can add 4. I can add 4, then 8, then 16, then 32, and so on. Here I can add 2 plus 4 plus 8, and so on. If k is at least logarithm, then I'm fine. Then easy. I think that just roughly that, because then this path is long enough, and if I greedily add proper number of vertices, I will achieve the goal, I think. It's a bit, just a little bit, like a splitting number into sum of powers of 2. If k is small, in particular, what if k is like 1 or 2? What about the task of making a balanced? Green means imbalanced. Okay. This. Given n, can I create here a balanced tree? For what n am I able to create a balanced tree? What is the most? Do I need to full the full the whole layer? If I add anything there, I also need to add it here. If I do that, I also need to add something here. Then I need to do this. So it's balanced only if it's a perfect full binary tree. That's an important observation. And finally, I understand why the problem isn't easy. My idea here is wrong, because I thought that I will just make those 2 imbalanced vertices and I will handle this in some way, maybe also adding things there. But it's impossible to create n by taking the sum of 2 powers of 2, by taking like one perfect binary tree, the other, and putting them into places, connecting them with an imbalanced tree, imbalanced node. N can be 2 to k plus 1, k plus log over the difference. I'm analyzing what Sachin said. N can be what? Plus 1 or k plus log of the difference. I think I have more possibilities than that. For sure I do, because like there is something imbalanced, and in particular I can do a connection of 2 full binary trees. It will be some power of 2 plus some power of 2, for k being 1. Okay, there is a big tree. It's mostly perfect binary tree, but somewhere this vertex is bad. Now I have an opportunity to say that you are perfect binary tree, you are perfect binary tree of possibly different sizes. But what can I say about this thing? This must be a perfect binary tree, and it will be of this size or twice bigger. Let's say that this is around 16, this is around 4, then this must be 16 or 32, because it must be close to 20. Let's skip the plus minus 1. This will be 16 or 32. I need to... Can I make it horizontal? Not like that. That works. Okay. 16 connected to 4. Then this must be connected to 16 or 32. Then this must be connected to what? Either it's 32 plus epsilon, or so in this first possibility it will be 32 or 64. In the second possibility it will be 32 or 64 as well, because it will be 48 plus something, and this must be not further away than twice. So for sure the sum of stuff here, it is from interval 36 to 50. What about adding with this? It will be 68 up to 114. This is still just within a single... this is between two consecutive powers of 2. So most likely, again, the next possibility here, this was one subtree, my left child of this, let's say this is the root, R. And it has one child and the other child. And this guy, if this is a perfect binary tree, this must be 64 or 128. And by continuing the choice, this or that, this or that, this or that, it seems that we will create any n. But let's understand this better from the very bottom. I think that we will put the imbalanced vertex as much down as possible. I'm doing this problem if somebody wants to Google it. The size is exactly 5. This is 5. Then the other one must be, what are possibilities, 3 or 7? Three or 7. Then I am 9 or 5 plus 7 plus 1, 13. And then you are 8 or 16. And in total we have the smallest possibility is 17, but by this jump I can have plus 4. So instead of understanding it as 9 and 13, it's 9 with a possibility of increasing you by plus 4. The right side is, oh, it's not 8, it is 7. It is 7 or 15. So 7 with possibility of adding 8. I am then 16 with possibility of adding 4 and possibility of adding 8. What's the left guy? 15 or 31. Then here we have 31 with possibilities of adding 4, 8 and 16. You're not adding 1 for non-leaf nodes? I am not doing that. You're right. Maybe then it will be more regular, because I didn't like the fact that this is bigger than power of 2, this is power of 2, this is smaller. Yeah, you're right. I was wrong. 5 and 3, this is in total 8, 9, plus 4. Oh, so this was fine. But then 9 plus 7 is 16, and I need plus 1 because I didn't count this vertex. This is not 16, you are 17. Here we have this, 32 in total, plus 1 because I need to also count you, that's 33. Cool. Cool. Can I do anything about the divisibility by 4 of n? I guess no. By continuing doing this, I will always get that I have here some power of k, like this is 2 to 5 plus 1, and I could to that add, this is 2 to 4th, possibly plus 2 to 4, possibly plus 2 to 3, possibly plus 2 to 2nd power, and generally I have 2 to k plus 1, and I can add this, add this, add this. Oh, and this is for one imbalanced vertex. If this problem was easier, I would now start to suspect that I'm going too deep into analyzing this one imbalanced vertex. Maybe we need to do something completely else, and it doesn't require any observations. But most of the time we do need to go deeply into something. This would mean P equal NP. I mean n divisible by 4. Maybe. I should change the name of Twitch stream. I will just change this to Code Forces hard problem with maybe a link. I don't know if that's the best method to do it, but also check out new Discord server. If you are into competitive programming or just watching my screencasts, then check it out. I'm pasting in the Twitch chat. I see that people already are pasting link to this. Thank you. I mean the problem. Still work in progress indeed, just like my other admin liar is saying in the chat. Okay. We understand what is possible for one imbalanced vertex. Assuming that it's the bottommost thing, is it any different if it's not in the bottom? Let's say what happens if it's here. This will be much quicker than the previous one. I will do it faster. If it's slightly bigger, and now I have option between this and that. This is 7 on the left. Here I have 1 with possibility of adding +2. Then I have 9 with possibility of adding +2. What happens when I move up? I have 7 or 15. Those are possible 2 perfect binary trees with sizes similar to this. The sum, that's 7 with possibility of adding 8. Then in total it's 16 plus the parent vertex 17, possible +2 and +8. Is there any other way to think about this? I think there is another way to think about this, because you know, we get some different solutions than what we have here. Here we have this plus possible smaller powers of 2, but not +2. Here we have +2, we don't have +4. What about subtracting? What if I draw a big full binary tree, then I will mark some imbalanced vertex, and I will cut some part of the tree, and from that we will get something smart, something interesting. And here I don't care. And let's say you are becoming imbalanced. Maybe something higher should. Okay, you are. Then I have opportunity. Okay, you are becoming imbalanced. I have opportunity to either cut 4 or cut 4 and cut 2 as well. So I cut 4 or 6. I have the full binary tree. I do this, and because I cut this out, I can also, then this subtree becomes smaller than the right subtree, and because of that, in that right subtree I can cut the leaves. The sizes are 2, 4, 8. And because this decreased a little bit, I can here cut 16. In total, I have here 63 vertices, because this is 16, so this is 32. In total, twice that minus 1. And possibly I can subtract Can I subtract anything? Here I can subtract 4 or 2 or 6. I cannot subtract 2. If I want to subtract 2 without subtracting 4, I will just move the imbalanced thing lower. Won't I? If I want to achieve -2, -8, -16, I will just place imbalanced guy here. I will cut this, and then I can keep cutting 4, 8, and 6. Okay, because I must cut this. 4 here is a must. If I don't cut 4 in the first situation, with imbalance being here, this will be balanced. So no, I need to cut you out. Something I didn't consider is the fact that I can cut something like I can cut 6 and 4, but I'm guessing it will not be necessary. Because already here, if I want to achieve this, I will place imbalanced on height corresponding to this value. Then I will cut 2, and I can keep cutting the bigger powers of 2, up to possibly 16. Is that okay? In particular, if we place imbalanced in the very root, we first subtract 16. Yeah, that's good. That's good. So express n as 63 minus some subset of differences. If those differences are not enough, then simply move down to the previous power of 2. Like if this is still bigger than n, then forget about it and do this. Let's say that this is 31 minus 4 minus 8, this is n. Then draw a full tree with 31 vertices. Then I want to first cut 4. And because I want to cut you out, then this becomes imbalanced. And also thanks to this fact, for your parent, the other subtree can be left without the leaves. And still there will be fine balance between this subtree and that one. This way I subtract 4 and I subtract 8. Cool, we solved problem for k equal to 1. The issue is k can be bigger. I also solved the problem for k greater than logarithm at the very beginning, I think. Most likely at the end my solution will do the same for any type of k. How can I quickly create one more imbalanced vertex? If I do something else in the leaves of my construction here, I'm afraid that I might completely mess something up. Any math tweet channels? I'm not aware of any, but you can, maybe the chat will tell something. Audio is too low? Is it? Is audio fine? 1, 2, 3, 4. If I now, as an extra, cut this out, then this becomes imbalanced as well. But I think there will be some extra consequences. Or maybe not. But if you have n minus 31 minus 2, that's an issue as well. What if green guy is already here? Then how do I easily make a second green guy? But if the first power of 2 I subtracted is at least 4, so first green guy is here, I think I can make another green guy by cutting the 2. But if you're asking me about one imbalance. If I have this 31 minus 2 minus 16, as I said, okay, I didn't say that. 16 is too big number to subtract, but this is equal to the previous power, 15 minus 2. I will use this. Given n, I will find the smallest possible perfect binary tree. So given 13 in the input, n equal 13, I will try to express it as small as possible, size of full binary tree, minus some smaller powers of 2. That was the first step, and that works for imbalance equal to 1. Once again, problem we are solving is inverse genealogy, and it's a hard problem from Codeforces. You can Google the title. Whenever I say Google, my phone wakes up, even though the assistant is off, Google Assistant. But still, it tries to unlock. Stupid phone. Can there be something wrong with me cutting this for imbalance equal to 2? If first green was at least here, I think there are no issues. It's not that I overflew any kind of balance. Because here I cut a bigger power of 2, so this is still a bit greater than those cuts. This is fine. Why subtract 8? What, here? Regarding here, we are given n, and then I will draw a full binary tree and I will subtract something. Subtract something, it means to cut some leaves out. If I have this if I have a tree that is a solution for k equal to 1, and generally for any k, can I always choose 2 leaves and remove them, and it will increase imbalance exactly by 1? For sure it's impossible to do forever. But if we have those red parts here, I can start from the root, always go down to a bigger subtree, keep going down, and remove eventually 2 leaves. Because I keep doing to bigger subtree, no vertex will be messed up other than the last vertex. I mean, well, this one stops having children, but this one. If you have 2 subtrees and each one is of size at least 5, or at least bigger is of size at least 5, and this one is 5 or smaller, and if this was balanced, then after removing those 2 vertices, it's still balanced. Only when there is 3 and 3 minus, only now it's possible to change something. I mean, if it's exactly 3 and 3, then removing 2 vertices from here makes you sick, makes you imbalanced. What I meant here is, if this is not imbalanced, then I'm only improving the situation. Not improving, but I'm not messing up the situation by removing 2 guys from there, from bigger child. This is why I suggested an algorithm of repeatedly going from the root down and always greedily choosing to which child I go. Imbalance means double height? What? I don't know what you mean, Sashin. Give me some particular values of n and k you are talking about, and describe what is going wrong if you think I described something badly. Okay, what if the solution is completely different? No, it's at least double height difference at least. I don't know what you guys are talking about. Give me value of n that I should analyze. Imbalance. What if imbalance is double height? I'm not saying that I came up with correct solution. It's not height difference, but at least double size. I never thought that it's anything about height. I never care about height. If I set height at any moment, I made a mistake. No. Here, what I'm doing on the right is I'm comparing sizes. And I'm saying if I remove 2 leaves from the left thing, I will decrease the size by 2. It's all about sizes. Okay. What if I'm going in completely wrong direction? What if something else needs to be done? If I decide about any subtree, there are 2 things important in that subtree. So maybe dp of n, how many vertices I used, and k. Okay, and now I can iterate over all possible connections of 2 subtrees. So iterate over n, iterate over k, and try to combine them. Then I'm able to detect if you become imbalanced. This way I can check for what values of k it's possible, because I will just print Boolean value whether dp of final and k is true. Maybe that will help. I think that for k equal to 1, any odd value of n, at least 5, is good. Also, this is polynomial solution. Maybe if k is small, like smaller equal logarithm than 20, then I will try to do this dp, and if it's big, I will use my very first solution. And if k is big, then I will do this pattern. A lot of imbalanced vertices, then this, and then I described what to do here, because I can keep adding some vertices not to mess up the structure. Oh, and that. So I had this, and I can keep adding those things. 4, 4, 2, 2, but also I can add 4 more, 8 more, 16 more. So this is for big K. For small k, do the dp. Hello, Majami. If somebody has just joined the stream, in first 30 minutes, I won the lockout round. I think if you go to YouTube, you can scroll to the past by 1 hour and see that. And from that moment, I'm trying to solve this problem E, inverse genealogy, from some recent Division 2 Codeforces contest. You can Google the name and read the problem yourself. You solved it for k equal to 1, right? Yes. But I don't know if my solution is useful. Turning more vertices imbalanced seemed like a bad idea. The limit for n here is quite small. So now I'm guessing maybe I went in completely wrong direction. What about just doing it kind of without observations? For n up to 500, I can solve it, I think, by doing Boolean dp to know if this tree is possible. For this n, this k, I will just combine in all possibilities. Can be improved with, for example, bit sets, but it will be at least n squared. But maybe for every k, there is interval of possible n's. Like for k equal to 5, we can do it with n from value 11, every odd value up to 53. If this is true, then this dp can be done in k squared. Let's try that. I will write slow dp, like just dp of nk, and I will check if for every k, for interval of values n, the solution is possible. Let's see. dp of 1, 0 is true. This is a single vertex, single leaf. For n1, for n2, I will combine two subtrees. From 1. For k1, for k2, dp of n1 plus n2 plus 1, and here k1 plus k2 plus, and here sometimes I will add 1. When n1 is at least double the size of the other one, or the other way around. Is it exactly this? So just it's starting from some n, everything is possible. With some exceptions, I see some exceptions here. First, let's skip even n. Okay. There are a lot of exceptions for k equal to 1. Maybe those are exactly powers of 2 minus 1. This is 1, 3, 5, 7. 11, 13. If not, dp of nk, k equal 1. Yeah, for those values of n, k equal to 1 is impossible. And additionally, we have here this strange case. K equal to 2 and n equal to 9. Oh, this is 9. I will write it down. Impossible. K equal to 1, n equal 1, 3, 7, 15, 31, and so on. And k equal to 2, n equal to 9. Other than that, it's just everything from the right of this. 1 and 3 don't really count, so maybe let's start like that. Those are only exceptions. Okay, now I can, assuming that this is true, and I will prove it by looking at bigger test. Yes, that's true. I will in some greedy way split it looking from the root. I can create a function. In constant time it will tell me if this pair n comma k is possible. Then I'm given some nk in the input. And polynomial but quite fast solution is iterate over size of left subtree and value k in left subtree. Then I know what n and k I need in the right subtree, check if both things are possible, and that's it. K equal to 1 is tricky, and k equal to 2 is tricky. If k is big, what if I always split into k equal to 3 and k minus 3? And just any values of n. Wait, so if k is smaller equal n minus 3 over 2, then solution exists? Yes, it's something like that. I don't want to get the exact formula, but it's around k versus n over 2. But, you know, we already suspected that from the drawings. Like here. This drawing. I said that we do this, and we also, this is k being around n over 2. And then we add some vertices here, like powers of 2, we can add 4, we can add 2. It's easy to believe that indeed it works for any big k, and for k equal to 1 there might be some issues. But I didn't realize that it's that regular. Only doesn't work for k equal to 2, this bit, and k equal to 1, those bits. First, let's create a function, and this function I'm guessing using dp. Assert that n is odd, otherwise why do you ask me? Return, let's think this is n equal to 1, 3, 5, 7. A pair 2, 7 is, for example, the first good pair. 2, 7, 3, 9, and so on. And then every bigger n is greater or equal to twice k plus 3. And there are some exceptions. and built-in pop count of n+1 is 1, then if n+1 is a power of 2. One, three, five, yeah. Assert okay. Now without any printing. Okay, here. Too slow. Okay. Yep. Let it go. Holy fucking shit, I just started learning Python and this looks like some NASA rocket science to me. But that will be true for any subject, any field, right? If you're just starting learning chemistry or foreign language and then you see something advanced, you will not understand it. So what can we do if make imbalanced things until we reach n,3? If the problem is something like this now, I'm here, let's say, I want to, because I'm given this n and k, I need to split into two subtrees and run recursively. And this way I will go down into two ones, like this thing and this one. As long as I'm going into ones, it's okay. It's a recursive function. Assert that f of nk is true, and what I brute force solution will be iterate over n1 and n2. If n equal 1, then return and do nothing. Iterate over n1. N2 must be this. Iterate over k1. K1 is smaller equal k. If f of n1 k1 and f of n2 k2, then do something. For I am bad, I am imbalanced. K2 is k minus k1 minus m bad. If this is true, then go recursively to n1 k1, go recursively to n2 k2. This way, and I am parent of those two. In a moment I will see what's the output format, but this is already not that bad, and I need to just speed this up, and this will be easy. It's for sure enough to just check some values of n or some values of k. What about trying to n to be around half of n? And same for k. Does it make sense? Assert false if you got here, and return. This will check that I'm indeed finding a tree. Oh, and I will say n comma k and 2k2. Oh, I know what I'm missing. mbad must agree with, actually I know mbad. No need to iterate over it. cannot print pairs. Some typo. I don't need new line because, oh, make pair. If f of nk, then reds of nk, no. Let's try n and k. 17 and 3. Assertion false. Seventeen 3 was split into 3 0 and 13 2. That would be two subtrees. And I guess 3 0 is then impossible to split. Yeah, 3 0 is impossible to split. Why? N1 can be 1. N2 will be 3 minus 1 minus 1. 1. Okay. I don't know if bracketing is correct here. Bracketing, I think, was correct. K2 is this. You can reduce question to k equal to 3 if you trust the data. I'm going to, most likely. There are two ways I can do. Either always try to half n, then I will have only logarithmically many calls, like the depth of recursion, then I can do stuff in linear time. Or either that, or I will always decrease n and k by O of 1. I will try both. I will try to get accepted with both. So what is happening here for N1 and 2? 1 0 1 0, but 1 0 is fine, right? Wait, 1 0 is not fine. One zero is not fine according to the formula. Oh, I'm printing only 0. Whoa. K equal to 0 is something very important. I completely missed that. For k equal to 0, it must be a perfect binary tree. But let's make sure. Yes. Now, here we need to say if k is 0, return the number of zeros in binary representation of n plus 1 must be equal 1. Add back the assert, checking that dp is equal to my heuristic function. It's okay. Why does it wait? Oh, it waits for other things. 17.3? Yeah. 17.3 was split like this. This is full description of a tree I will get. Let's do the output. There is max n, parent, and I will pass here next, maybe just next this one. If I move down, I will just get an argument. The root. Initially root is 1. His parent will be 0. I can use a full name here. And when going down to 2 subtrees, I will say parent of root plus 1. I will number them. If I am 5, then this child will be 6. Parent of root plus 1 is root. Parent of root plus n1, because that's how many vertices are there on the left, plus 1 is equal root. And then do this with root plus 1. Do this. Parent of I. Let's just do it once. Return 0. Okay. Maybe we will get accepted in minutes. 3-0. That's their output as well. I could theoretically now submit this just to see if I don't get wrong answer. But let's try to finish and then submit when I think it's fast enough. Iterate over n1 and over k. I bet that it's better. I bet that it's good to say that one of those 2 subtrees is small. But k1 cannot exceed n1. And if that's the case, then first I will try size 1 on the left, size 3, size 5. So I guess that this is already small. Okay, fast. I will also try in a moment, if I get accepted, doing this for splitting into halves. What's going on? I'm asserting this, and it's a very bad idea. What's up, chat? Accepted. Then we got one 2800 difficulty today. Then it's a nice day, isn't it? Okay, I bet that I could also do n1 is equal to this smaller equal. This will be the distance from the middle for int n1 in n over 2 minus diff, n over 2 plus diff. This is order. Oh, what am I doing? Just create all possible n's. Instead of some stupid hacks. And this is linear, so it seems bad. But do this. To make it faster, I will resize first. Actually, I anyway am going to sort. Do this. Sort. Sort by the distance to the middle and consider things in this order. That's it. Let's say if not that, then continue. It's slow. It's very slow. Won't it be true here that it's always possible to split in half? Can you prove that one subtree is small? Likely I can, but I don't want to. Mind-hands coordination is awesome. It's just about being good at solving problems plus having good typing speed. No, I wouldn't call it coordination, but you can call typing speed a good coordination. What's this? Oh. In line 63, I'm doing something illegal. What I used a moment ago is called the GDB. Now it should be sorted from the middle, and maybe now it's faster because I had the bug. Maybe it mattered for very small n, like 30 wasn't detected. And then something bad happened. I'm not sure. No, it's still very slow. It's very small for big K. I thought that it doesn't matter. I thought that always I will be able to split with around in half, and then it should not matter. See, for 100,000 and small k, it's fast. For 100,000 and bigger k, it's very slow. Do I understand this? Maybe then it's impossible to split into two equal halves. I'll just print this. I'm splitting big stuff into equal parts, roughly equal parts. Let's say if n is big. And don't print the output. So I didn't have a new line after all the parents, but whatever. It's not necessary. Oh. If k is around half of n, then you cannot split into equal parts because the only solution is that path that goes only to one side. That's why it's wrong. That makes a lot of sense. I tried to get log n from kind of divide and conquer, where I always split in half, but it's impossible in those cases I drew at the very beginning of solving this problem. If imbalanced vertices need to create a path to the left, is there an easy way to fix it so that I could still do linear stuff here, like the sorting? Instead of n over 2, I can put some other number here, like n minus 2 minus k. But then it's bad that I'm doing something in linear time here, because n always will decrease just by 2. So this cannot work. Only my first solution can work. Do I have a mechanical keyboard? I don't think so. See FAQ, there is my keyboard there. Well, then it was a bad idea to split into two almost equal parts. Let's see what editorial says. Tutorial. I like the problem. I don't remember now who suggested. I'm scrolling up to thank that person. This is 1379. Kaipar 16. I think you suggested the problem. Thank you. It was a fine problem. I wasted first half an hour because I went in completely wrong direction. I didn't use any of the observations I made. Let's see the editorial. The number of critical nodes can be more than this. Critical means imbalanced. It is obvious that caterpillar tree have maximum number of critical nodes. I wouldn't say obvious, but sure. If there are 0 critical nodes, then n is almost a power of 2. Yes, I'm proved by contradiction. If there are 1 critical nodes, then n isn't almost a power of 2. Okay. How to construct an example with 1 critical node? They find the range of powers of 2. Oh, they always go to n minus 2k minus 1. If n is greater or equal 13, then we can just make one subtree of size 1. In other cases, we should pre-calculate answers. What is this shit? Editorial shouldn't say, oh, for values bigger than 13 this works. Why does it work? Then why don't you need here 1000? Stupid editorial. I mean, that's fine for a solution to guess something, but in the editorial you need to be able to understand it. I mean, the author needs to explain it. I'm looking for other solutions. This is what you should also do while upsolving. If you spend 1 hour solving a problem, it doesn't hurt to spend 5 minutes more looking at editorial and the comments. Then I'm seeing maybe somebody will give me some extra proof, and in the future I will know better about something similar. Maybe there will be an alternative solution. No, nothing. Can you prove that one subtree is small? That's what I said. Yeah. Everrule storm. This basically comes from, when I showed you the tables of ones and zeros. If it's regular from some moment, then yeah, it should be easy to say it's... Oh, okay. Here's my proof, assuming that the shape was indeed like a lot of ones and zeros. Let's say if 0... Okay, if starting from this moment it's indeed like that, then it's stupid that I wrote that whole recursive solution, because just from this one I will go recursively to this one by decreasing n by 2 and k by 1. That's easy, and I can do it whenever I'm here. I do it. Just what I would do is for k at most 4, then I do something special, because already for k4 I cannot from this cell go to this one. Assuming that this is always true for bigger k and n, that there are only ones on the right from the main diagonal, it's trivial to prove that for this part it's good to go just top left with recursion, decrease n by 2, k by 1. Remember that columns are only for odd n. And so moving by 1 to the left means decreasing n by 2. But here it stops being correct, so here we must do something special. This is the first such moment. This is k equal to 4, n equal to 1, 3, 5, 7, 9, 11. I guess this is why they wrote 13. Okay. You don't put such a number 13 in editorial without explaining why it's 13. I have a feeling that for larger k, the gaps between the random zeros become very large. Maybe that's the case. I'm sure there is an editorial. I'm sure there is a proof. But, this thing for 2 first rows, it was very regular. It was powers of 2. Here, this 0 is suspicious. If only first 2 rows were like that with powers of 2 and this was 1, then I would be more sure about this being regular. Are there probability problems in coding interviews? Yes, they happen. Please do challenge on LeetCode, please. Soon. What am I doing? I just solved this code forces problem, but unfortunately after this I'm finishing the stream. I solved this one. You can watch the video on YouTube. And yeah, that's everything. For the last time I will plug in my Discord, new Discord server from yesterday evening, created yesterday in the evening. So it's small and growing. On Twitch, if you scroll down, there is here a link. I will paste it for you. And also if you are on YouTube later after the stream, the link is in the description. Please end with a type racer. Okay, we can do 2 type racers. Am I logged in? I'm not. I warned everybody that I'm only using Twitch chat today, so I will paste the link only in the Twitch chat. I think I will in general abandon YouTube chat, or just YouTube streaming in general. I'm thinking about it. No, not this. I will show you a screen in a moment, along with a link. Type racer. Link is in the Twitch chat. Good luck to 2 guests. After this will be over, there will be automatically the second one. Oh no, I don't see anything. $97. Generally, in English, if I don't make a lot of mistakes, I have around 100 words per minute. Congrats, Sandro, for 2nd place. The next one will start in seconds. 70, good for me. Then congrats. I did a lot of this. If you see here in top right, I did 1000 races. Each of them is around, what, a minute? Then I practiced around 20 hours on this website alone. I started practicing seriously typing 5-10 years ago. I don't remember. Just like with competitive programming, you must spend some time to become good. But obviously don't start from something like this. You should start from programs designed to teach you typing. You can Google typing practice or something like that. You will find plenty of free websites and programs. And there first you will type just with F and J, just 2 index fingers, and that will become more and more complicated. But this way you learn proper placements of fingers. Use monkey type or keyboard or WTV. I don't know those programs, but if Google will give you a lot of them. If you run something and you really hate using it, then try something else. But other than that, just use it. To be honest, I mixed a few platforms to make things interesting. I will show you programming Linux in a moment, just after this. $122, is that my highest score ever? Best race, 122. That was my best. I didn't make a single mistake. Or maybe I just memorized the whole Harry Potter saga, and this is why I knew all the words. Nice. 100% accuracy matters a lot. It's just like automatically plus 10 words per minute. Okay, enough of this. You can make one more. Congrats, Ryan, for 2nd place. So I will let you do one more. You can just, the same link will work. But I will show you something else here. For programming keywords, I use type speed in Linux. How do I make this bigger? I don't want to make it full screen. Type speed. You can practice with some English words, but also with C# keywords. And those will be more programming related. Volatile, brackets, warning with a hash. This will teach you special characters. Struct, in, line. You can make it, you can make your own dictionary, and then it would be better for practicing for competitive programming. Because there are a lot of words here that we don't really use in competitive programming. But const, string, continue, where, maybe not where, but int, throw, using this, a lot of them are useful. It goes faster and faster. You have 10 lives, but I believe this is only for Linux. Though, I don't know, to be honest. Maybe there are some instances in other systems. And obviously you shouldn't look at the keyboard when you're typing. That would slow you down a lot. Damn it. I cannot type hashtag correctly, a hash character. Maybe next time I should just skip words with a hash. Three more lives. 7 mistakes. Oh, 87 words per minute. Obviously, English is easier than single programming words, because in English, when you type the whole sentence, it has some sense in total. You don't need to look at every word separately. I am going to the beach. If you think about it as one sentence, here, if those are in different places and they are unrelated to each other, it's much worse. Apparently on this computer I didn't practice a lot, but again, when I did practice many years ago, I would do tens of this. Just when I have free half an hour, I would do this for like at least 20 minutes. I make mistakes in every 2 characters, then maybe slow down. I had this challenge with my friend, who will get more points here without any mistake. We did that during some programming camp, but we absolved already all the problems, and we tried to. Then you need to type quite a bit fast, a bit slower, but not really that much slow. I will try to now get everything correctly. Like, implicit was an easy word. Now I need to look to get at line again. The hash I often mess up, but if I type very slowly, I don't know. I'm not really trying to type that slowly. But if you don't try to hit 2 keys in a very short span of time, you should be able to get 100%, right? If you get a lot of errors, I really recommend this method. Or maybe try clicking things very hardly, like with big strength, and then it's hard to be in the wrong place, because you are really trying to hit every key. So far, no mistakes. But protected. Some words are more difficult than others. Interface. If, uint, go to. char switch. I think this is a very nice practice for the correctness. Okay, I will try to speed up, but still I will finish whenever I make a first mistake. And even if that's a single character. Oh, I thought that I made a mistake. Typo ratio 0%. And even though for half of this I tried to type slower, and in the second half still I wasn't trying to be fast, I was only trying to be correct, I got better, significantly better score than in the previous run. Actually, how to interpret this? Score is the total number of characters. Like if I type correctly a 5-character word, I will get 5 points. Now I got slower words per minute, but what does it mean? I'm trying to understand this. Even though I typed slower, this is not related to accuracy. This is the total number of characters in my correct words. Maybe just this counts also those words where I made a single typo, the word had 8 letters, and that was counted towards my speed. It's a bit stupid. Anyway, you will create more stuff, like you will make bigger code in the same amount of time, I believe, if you try to type correctly. And obviously I will not get 100% every time. It's just, I was also lucky here. But try to deliberately be only correct, not fast. Yeah, the name of the program is TypeSpeed, it's this. You can use this in Windows Subsystem Linux. You're welcome to do it. If you already use Linux within Windows, then sure. If you don't set up Linux only to use this single program. Checking if Sandro and Ryan are in the chat. No, the guys who, I think nobody is doing this anymore, but they had good scores here. Is this inbuilt? You need to install it. But installing anything in Linux is as easy as this. Sudo apt install TypeSpeed. If you type this command, you will install TypeSpeed. No, I don't play CS. Okay, that's it. See the description for my Discord server. It's quite new. And because of that, it's nice and welcoming to beginners for now. Yeah, see you. Thanks for watching. Bye bye.